Bismillahirrahmanirrahim. Let's begin with today's session. And you
Yes,
can see the topic ion polarization, right?
right.
Okay, beta. Let's see what do we mean by the word ion polarization. What are our learning objectives today? So many things we'll be having. Let's move on. If you can go through the learning objectives one by one, slowly, please.
Ion polarization definition, factors affecting ion polarization, thermal stability of group 2 carbonates and nitrates.
Okay. I believe that the word polarization is entirely new for you. Am I right?
Right.
Absolutely new for you. You don't have any idea about this word. You never came across with the word polarization up till now. But
Yes.
the word thermal stability you are very much familiar with,
Yes, yes,
right?
obviously. Yes.
So just give me some idea about what do you mean by the word thermal stability of a compound?
Thermal stability of a compound.
What do you mean? How would you explain to some student who is junior than you and he is asking, okay, let me know something about what is meant by the word thermal stability of a compound?
Uh, it could be a material that decomposes under the influence of temperature.
Absolutely, it's the tendency of a
Yes,
compound to decompose, to break down into its components under the influence of heat,
temperature.
right? Under the
Yes.
influence of heat. Absolutely right. Second thing, you are very much familiar that different compounds have different thermal stability. Am I right?
Right. Yes.
In your ordinary level, you have learned about it that
Yes.
more reactive metal, its compound will be more thermally stable, right?
Yes. Right.
And they need a different temperature to decompose, right?
Right.
More thermally stable compound, they decompose at a higher temperature, right?
Right.
And less thermally stable compounds, they decompose comparatively at a lower temperature, right?
Right.
This is something which you are carrying from your initial classes, which you studied in O levels and AS as well, right?
Right.
Okay, beta. Let's move on. Again, I am dragging you towards your past. Some previous knowledge I would like to recall with you. In your ordinary level, you learned, you were taught about the thermal stability of various compounds. Am I right?
Yes.
If you consider the group 2 carbonates, suppose that is
Yes.
magnesium carbonate, calcium carbonate, strontium carbonate, barium carbonate, etc., you learned that more reactive the metal, more
The
thermally stable compound. Am I right?
right.
Now, these are the three consecutive metals of group 3: magnesium, then calcium, then strontium, right?
Right.
And you know, reactivity increases from magnesium to strontium, right?
Yes.
So, now think about this overall scenario and tell me which of these carbonates need a highest temperature to decompose.
Strontium.
Absolutely, absolutely, because this is the knowledge which you are carrying from your O level syllabus, right? Because strontium, you learned that it is more reactive metal in these three, so its compound will be more thermally stable. They will require comparatively higher temperature to decompose. Am I right?
Right.
And I hope
Right.
you are understanding each and every word.
Yes. Yes.
That's correct. You learned that more reactive the metal, more thermally stable compound will be. What do you mean by the more reactive metal? Now over to you in terms of electron transfer.
More reactive metal in terms of electrons transfer.
Let me make your work easy. Uh,
Yes.
will it be losing electron with great ease, or it will be losing electron with less ease?
Losing electron with great ease because it
Absolutely,
is more
absolutely,
reactive.
absolutely.
Yes.
That's great. That's very nice. This is something which
Yes.
you are carrying from your previous academic levels, right?
Yes.
That's great. That's very nice. So you have the idea of more reactive metals that they have the greater tendency to lose the electrons, the valence electrons, I mean, right?
Yes.
The next one. Yes, please.
What do you think about atomic radii of more reactive metal, large or small? It will be large.
Absolutely. That's correct. That's correct. And due to the large atomic radii, their valence electrons are far away from the nucleus,
Um, yes.
and less attraction of the nucleus, more shielding, so many things you used to say
Yep. Yes.
in your AS
Yes.
level. That fire, less energy is required to remove the valence electron from the valence shell. Perfectly fine. This was the initial discussion to make a background for the polarization, right?
Right.
And I hope you are grasping each and every word of the discussion.
Yes. Yes. I am.
Alhamdulillah, Alhamdulillah. So let's move ahead. Again, something which you are very well familiar with. It's a
Yes. More.
model of ionic lattice. All
Right. I.
absolutely right. All ionic lattices are made in this way, that ions, oppositely charged ions, are repeatedly arranged in a three-dimensional regular pattern to make a giant ionic lattice structure.
Yes.
Clear?
Right.
No confusion?
No.
That's great. Let's move ahead. Now, straight away, I am coming towards the topic which I wrote in the learning objectives. That first of all, we will define the word, what is meant by ion polarization. Now, I am going to define the word ion polarization, right?
You're right.
Okay. From the giant ionic lattice structure, which I just showed you in the previous slide,
Yes.
I just pulled out the one positive ion and one negative ion from there. Let's see. This is a positive ion, beta.
Yes.
And this guy is the negative ion. Suppose I pulled it from the giant ionic lattice just to show you how the two ions are attached, bonded by a strong ionic bond in the ionic lattice, right?
Yes.
Okay. So let me explain you one thing. This positive ion, or the cation, it attracts the electronic cloud of the negative ion, right? Because
Right.
negative ion has more number of electrons, right?
Yes.
So what we believe, that there is an electronic cloud in the negative ion, in the anion, and that electronic cloud is being attracted. This whole electronic cloud is being attracted towards the cation. Am I right?
Yes.
Okay. And when this electronic cloud will be attracted, when this electronic cloud will be attracted, this attraction of cation will cause in the disintegration or distortion in the electronic cloud, right?
Right.
So please remember, if a cation is causing more attraction on this electronic cloud, this electronic cloud will be more distorted, more disintegrated, more disarranged, you can say, right?
Right.
And whenever a system goes through disintegration, whenever a system goes through distortion, what do you say? The system becomes more stable or less stable?
Less stable.
Absolutely right. That's correct. So please remember here, grasp the concept that if a cation is putting more attraction on the electronic cloud of the anion, there will be more distortion in the electronic cloud and there will be more disintegration, right? Okay, I hope you are understanding.
Yes, yes.
Okay, now this is known as polarization. This disintegration, this distortion of ionic, this distortion of electronic cloud in the anion by the attraction of the cation, this is known as polarization, the simple definition of the word polarization. So
Yes.
whenever we consider the attraction between a cation and the anion, the cation tends to attract the electronic cloud. Due to this attraction, the
Mm.
electronic cloud of the anion, it becomes distorted, disintegrated. This phenomenon is called polarization, right?
Exactly.
If you can read it for me and just explain in your own words, just read it once.
The positive charge on cation in an ionic lattice may attract the electrons in the anion towards it. This results in a distortion of the electron cloud of the anion. We call this distortion as ion polarization.
Is this okay?
Yes.
So attraction of the cation on
Yes.
the ionic cloud of the anion causes
This
distortion,
causes distortion,
causing
yes.
distortion of the
Means that it
electronic.
is polarized.
Absolutely. So this is known as polarization. So
Yes.
polarization means more polarization, more distortion. The system will become more stable or less stable.
Less stable.
Absolutely. Now remember this word. More polarization means more distortion in the ionic lattice, in the
Uh,
electronic cloud of the anion, and the lattice will become less stable, right?
right.
That's correct. So, should I believe that you grasped the basic definition of ion polarization?
Yes, yes, I have.
That's correct. Let's move ahead.
Yes. Factors affecting
Yes, please.
factors affecting ion polarization.
Okay. These are the
Charge,
fact these are the factors which affect the ion polarization. Number one, charge
charge,
density of the cations, right? And you know very well, smaller the cation, more will be the charge density,
yes,
right? And larger the cation, less will be the charge density.
yes,
So smaller cations, they have more charge density. So more charge density means they will show more attraction or less attraction on the electronic cloud.
more attraction.
Absolutely. More the charge density, smaller size, more charge density means they will be attracting more to the electronic cloud. More distortion,
Yes,
more disintegration, and
yes,
it will cause the stability or instability.
less stability.
Absolutely right. So please grasp this concept. Second, an anion is more likely to be polarized if the cation is small. Again, the same thing. Smaller cations, I told you, smaller cations, they have a large charge density. They have a tendency to attract the electronic cloud of anion more, right?
Yes,
They cause more polarization, they cause more disintegration. more distortion in the electronic cloud of the anion, right?
Right.
So smaller the cation, we can say that smaller the cation, it has more polarizing power, right?
Yes.
More polarizing power. And larger cations,
Less polarizing power.
that's very simple. Any confusion?
No.
Okay. So the second factor which affects the ion polarization is the charge of the cation and anion, right?
Yes.
Greater the charge of the ion, more will be charge density.
Yes.
And more charge density means more attraction of the cation on the electronic cloud of the anion.
Yes, and more polarizing power.
Ah, more unstable, the lattice will become more unstable, right?
Yes.
That's right. Similarly, the charge of the anion affects the polarization, right?
Right.
So please remember these factors. So mainly, if I summarize the factors which affect the polarization, the first one is the ionic radii.
Mm.
The first one is the ionic radii, and the second one is the charge of the ion.
Mm.
Am I right? Am I right?
Right.
Okay. If I ask you to please explain in a few words how ionic radii influences the polarization.
Ionic radii influence.
How it
Polar-
influences.
how does it influence? Like, do I have to tell in
Okay,
the?
okay, wait. Smaller ionic radii, smaller radii means more charge density,
Yes.
stronger attraction of the cation on the electronic cloud of the anion,
Yes, and more
more
at
polarization, more distortion,
yes. So the
less,
polarization.
less will be the
Yes.
stability, right?
Yes.
That's it. So
Okay.
smaller cations have more polarizing power, right?
Yes.
Similarly, the ions with a greater charge. Yes, you can explain it, please.
Yes, the ions with a greater charge will also have this effect,
Larger effect on the polarization or less effect on the polarization?
larger effect.
Absolutely, because they have greater charge, they have a greater
Greater
tendency to attract
than
the
attract and
electronic cloud. Yes. Got it?
yes.
Any question, beta, up till here?
Oh,
Let's move on.
yes.
Now we will link up the ion polarization. We are going to link up the ion polarization and the thermal stability of ionic lattice. And I know you have some initial idea about it, that more polarization means more stable or less stable the ionic lattice.
More polarization means less stable the ionic lattice.
Absolutely right. So you have some initial idea about the relation between
Yes.
the ion polarization and the thermal stability of the ionic lattice, right?
Yes.
Okay. Just read it, please.
The thermal stability of group 2 carbonates and nitrates. Group 2
This is
carbonates
this is the
compose.
part of your syllabus, beta. You
Yes.
must know about the thermal stability of group 2 carbonates and group 2 nitrates, and
I've
you
learned in AS2, group 2 carbonate stability of
absolutely, but you
sulfates, carbonates,
yes, yes,
hydroxide.
you are right, but you did not learn about the polarization over there.
Yes, obviously.
Now you have to link up this thermal stability with the ion polarization, right?
Right.
That's right. Yes, please. Move ahead.
The group 2 carbonates decompose to their oxides and carbon dioxide on heating. Yes.
I hope it's very much understandable for you.
Yes, that's a fair definition.
That's right. So carbonates, whenever they are heated to a certain temperature, they are decomposed into their oxides and carbon dioxide gas is given out. Is this okay?
Yes. Yes.
Okay, let's move ahead. Take a minute and look at the slide, and then I will discuss with you the outcomes that what you deciphered from this information. Take 2 minutes at least, right?
Okay.
I hope you have gone through this information which is given in this
Yes,
table.
I have.
You are provided with the list of group 2 carbonates, that is magnesium carbonate, calcium carbonate, strontium carbonate, barium carbonate, and
Right.
with them you are provided with the decomposition temperatures. Am I right?
Right.
And you can see that downward, as we are moving down the group, the thermal stability of these carbonates is increasing, right?
Yes.
Absolutely. Okay. It means which of these carbonates will decompose at the highest temperature?
Barium carbonate.
Barium carbonate, absolutely right. So BaCO3, it has the greatest thermal stability. So its decomposition temperature will be the highest in the group, right? I hope it's fine for you.
Yes.
That's correct. So let's look into the reason, the explanation, and the examiner's expectations from the learners. Same, same trend will be used for group 2 nitrates, group 2 hydroxides. Am I right?
Yes. Sulfates.
Absolutely. Same trend will be used to describe the thermal decomposition, right? Or the decomposition temperatures of the compounds of group 2. I hope it's fine.
Right.
So
Yes.
down the group we will be moving, thermal stability increases, right?
Right.
Let's look into the explanation. Yes, please.
Thermal stability of group 2 carbonates increases down the group. Ionic radii of cations increase. Charge density decrease while the radii of anions remains same. Less polarization, less disintegration.
Am I right?
Yes.
3 points, 3 marks. Make sure that you are understanding each and every point, please. Make 100% sure. I hope you got it.
Yes, I got it very well.
So, one word with which we will be heading towards the conclusion of this class: more polarization in ionic lattice makes it more stable or less stable?
More polarization will make it less stable.
Absolutely right. Any confusion?
No.
That's correct. Let's move.
Right.
In this,
Decomposition of group 2 nitrates.
now, X is the group 2 metal. You can put any metal instead of X, that is magnesium, calcium, strontium, barium, etc. Right?
Yes.
You know very well whenever group 2 nitrates decompose, they turn into metal oxide and
Yes.
nitrogen 4 oxide or nitrogen dioxide, we call it. and
Yes, and all
oxygen gas. Is this fine?
right.
By the way, do you remember the color of this NO2?
Brown.
Oh, that's very nice. Please remember this observation. This observation
Yes.
is asked in the past papers, right?
Yes, brown. Yes.
So this metal oxide will be a white solid, brown gas, and a gas which,
Uh,
what we say, what is the test for oxygen gas?
Relights
He
when.
lights the glowing splint, right? So remember these observations. Okay, let's come to the point. Yes, please.
Thermal stability trend for nitrates of group 2 is same as that of carbonates observation.
You know the observation we just discussed.
Yes, we have discussed.
Any confusion?